Transcription is the conversion of DNA into RNA. In eukaryotes, transcription takes place in the nucleus while it also occurs in the cytoplasm in prokaryotes. It can be divided into three stages: initiation, elongation, and termination. Initiation begins with RNA polymerase binding to a new DNA strand and unwinding them. Unlike DNA polymerase, RNA polymerase does not need a primer to start the synthesis of a new strand. Instead, they use a promoter region that consists of a combination of nucleotide bases that determine where transcription will begin. Initiation is followed by the elongation stage. In this stage, RNA polymerase synthesizes an RNA transcript unit that is complementary to its DNA template strand. The two DNA strands are unwound as the RNA polymerase moves downstream. The two DNA strands later bind again after the RNA polymerase has passed. Both RNA and DNA polymerase are similar in that it can only move in a 5' to 3' direction. Multiple RNA polymerase can work on a single strand of DNA at once, boosting the amount of RNA strands produced. This comes in handy later on during translation when proteins are needed in large amounts. Termination is the last stage of transcription. In prokaryotes, a termination sequence calls for the attachment of RNA polymerase and also the newly made RNA transcript unit. In eukaryotes, a polyannulation sequence is used to detach the RNA transcript from the polymerase, resulting in a pre-mRNA strand. The RNA polymerase does not attach and continues synthesization.
After the initial transcription of DNA to mRNA, it is first altered before use in eukaryotic chromosomes. Firstly, the ends are adjusted with the 5' end being synthesized first. The 5' end receives a 5' cap. A modified guanine nucleotide with a 3' end receives a poly A tail, a long stretch of 50 to 200 adenines. These alterations assist in the mRNA's resistance to degradation, facilitation of export, and future attachment to ribosomes. Once the ends have been altered, mRNA splicing must take place. Primary gene transcripts start with both introns and exons. Introns are non-coding regions with a segment of pre-mRNA that is cut out to leave exons, the coding region of mRNA. This process is facilitated by spliceosomes, catalyzed by sRNA, a joint assembly of SNRPs, and other proteins. Spliceosomes recognize splice sites along free mRNA, excising introns and leaving exons which become connected together. Introns may be seen as junk by interfering with protein synthesis in eukaryotes, but in fact, they may serve a useful purpose. By having optional interchangeable introns, a gene may code for multiple proteins, called alternative RNA splicing.
Translation consists of three primary stages: initiation, elongation, and termination. In initiation, a small ribosomal subunit binds to mRNA at 5'. At the same time, an initiator tRNA molecule recognizes and binds to a specific codon sequence of the same mRNA molecule. A large ribosomal subunit then joins the newly formed complex. The initiator tRNA resides in one binding site of the ribosome called the P site, leaving the second binding site, the A site, open. When a new tRNA molecule recognizes the next codon sequence on the mRNA, it attaches to the open A site. A peptide bond forms connecting the amino acid of the tRNA in the P site to the amino acid of the tRNA in the A binding site. Next is elongation. As the ribosome moves along the mRNA molecule, the tRNA in the P site is released, and the tRNA in the A site is translocated to the P site. The A binding site becomes vacant again, and so another tRNA that recognizes the new mRNA codon takes the open position. This pattern continues as molecules of tRNA are released from the complex, new tRNA molecules attach, and the amino acid chain grows. The last step of translation is termination. The ribosome will translate the mRNA molecule until it reaches a termination codon on the mRNA. When this happens, the growing protein called a polypeptide chain is released from the tRNA molecule, and the ribosome splits back into large and small subunits.